Hey everyone, and welcome back to Self-Study Prep. This is your home base for crushing the AP Computer Science A exam. I'm your host, and today we are starting at ground zero, the absolute beginning, the foundations of Java. So, if you've never written a single line of code in your entire life, don't worry, you are in exactly the right place. We're going to build this thing from the ground up, one step at a time, starting right now.
So here's our game plan for today. First up, we're going to get into the logic of code, which is really about how computers think. Then we'll check out the essential tools that every programmer uses. After that, it's time to get our hands dirty and write our very first program in Java. Next, we're putting on our detective hats to hunt down the three main types of errors you'll run into. And finally, we'll wrap it all up with a crucial AP exam reality check to see exactly how this stuff shows up on test day. Let's do this!
Okay, let's dive right in. Before you even dream of typing out some code, you have to understand the fundamental relationship between you and the machine. And here's the secret. It's not about being a math whiz, it's about being logical. See, computers don't have common sense or intuition. They are incredibly powerful, but they're also just, well, they're empty boxes waiting for us to give them very, very specific instructions.
And that brings us to our very first key term, the algorithm. Now this sounds super technical, but an algorithm is really just a fancy word for a recipe. It's a precise, step-by-step process for getting something done. This reveals the computer's one big weakness. It's completely mindless. It can do billions of calculations a second, but it has no idea what you want it to do. You have to spell it out. Every single thing you do on a computer is just an algorithm running in the background.
To make this super clear, think about making a peanut butter and jelly sandwich. If you told a friend, hey, make me a sandwich, they could figure it out. But if you tell a computer that, it's just going to sit there. It has no idea what you're talking about. You have to give it an algorithm, just like the one on the screen. Get bread, open the jar, spread the peanut butter. Every single step has to be broken down into its smallest, most basic action. You literally can't assume anything.
Now, here's the crucial part. The order of those steps, it is everything. This concept is called sequencing. In Java and most programming languages, the computer reads your commands one at a time from top to bottom in the exact sequence you wrote them. So what happens if you mess up the sequence in our sandwich recipe? You try to spread the peanut butter before opening the jar. The whole process just fails. The computer can't just fix your mistake or skip ahead, it just stops, gets confused, and the program breaks. And that right there is programming in a nutshell, creating a perfect, logical sequence of steps.
Okay, so this leads to the next logical question. We know we need to write this super specific sequence of instructions, but where do we actually write them, and how? This is where our toolkit comes into play. We need some specific software to help us write our algorithms and then translate them into a language the computer can actually understand.
Now, you technically could write Java code in a simple program like Notepad, but that would be like trying to build a house with only a plastic spoon. It's just not the right tool for the job. Instead, professionals and students use something much more powerful called an IDE, which stands for Integrated Development Environment. Just think of an IDE as a super smart word processor that's built specifically for coding. It does all this cool stuff like color coding your text, auto-completing commands, and even pointing out your mistakes before you even try to run the program. It's an absolutely essential tool.
And here is a really critical piece of the puzzle. Computers don't actually speak Java. No, really. Java is what we call a high-level language. It's designed for humans, like you and me, to read and write. The computer's real native language is machine code, which is literally just the long series of ones and zeros. So, how do we bridge that gap? We use a special program called a compiler. After you finish writing your code in the IDE, the compiler acts like a perfect translator. It reads your human-friendly Java code and converts it, line by line, into the machine code that the computer can finally understand and execute.
And this quote right here perfectly captures the compiler's personality. It's your first line of defense against mistakes, but man, is it picky. It's like the strictest grammar teacher you've ever had, the one who demands absolute perfection. If you forget a semicolon, misspell a command, miss a single tiny piece of punctuation, the compiler will flat out refuse to do the translation. It won't guess what you meant. It'll just stop and spit out an error message. And if there's no translation, there's no program, period.
All right, enough theory. It is time to see what actual Java code looks like. We're going to walk through the classic Hello World program. This is the traditional first program everyone writes when they're learning a new language. Now, I know the syntax might look a little intimidating at first, but don't worry. We're going to break this thing down line by line, piece by piece. You got this.
And here it is, the bare-bones skeleton of pretty much any Java program you'll ever write. First up, public class hello world. In Java, all of our code has to live inside something called a class. Just think of a class as a container or a blueprint for our program. We've just named ours hello world. Now those curly braces, get used to them. They are huge in Java. They define a block of code, so everything inside these two braces belongs to the hello world class. Then inside that, we have the most important line, public static void main string array args. This whole thing is called the main method, and it is the official starting point for your program. When you tell the computer to run your code, it looks for exactly this line and starts executing whatever is inside its curly braces. Now for now, you can just memorize this line. Think of it as the ignition switch to start the car. It's the magic spell that kicks everything off.
Okay, let's actually make our program do something. Inside the main method, we add this one line, system.out.println hello world. This command is a built-in Java tool that, you probably guessed it, prints a line of text to the console. That's the little output window you'll see. The text we want to print, hello world, goes inside the parentheses. Now, any text you wrap in double quotes is called a string literal. It just means print these characters exactly as they appear. And finally, the most important and most often forgotten piece of punctuation in all of Java, the semicolon. Every single complete statement in Java must end with a semicolon. It's like the period at the end of a sentence. Forgetting it is probably the #1 mistake every beginner makes. Don't let it be you.
You know, as your programs get bigger and more complex, you're going to want to leave notes for yourself or for other people reading your code. We do this with comments. Comments are lines of text that the compiler just completely ignores. They are purely for human eyeballs. A double slash starts a comment that just lasts for that one line. A star starts a multi-line comment, which is awesome for longer explanations, and you just end it with a //. And that third one, /* is a special JDoc comment, which is used to automatically generate official documentation for your code. Pretty cool stuff. Now, a really professional way to use comments is to document your preconditions and postconditions. A precondition is basically a rule that must be true before your code can run. For example, a precondition for a division method might be that the number you're dividing by isn't 0. A postcondition is what you guarantee will be true after your code is done. It's like writing a little contract for your code, explaining how it's supposed to work. This is a hallmark of really good programming.
All right, let's be honest for a second. A huge part of programming isn't writing new code. It's fixing broken code. We call this process debugging, and it basically turns you into a detective. Your job is to find the culprit when things go wrong. And to be a good detective, you need to know the 3 main types of criminals, or errors, that you'll be hunting down.
So, here are our 3 main suspects. First, you have syntax errors. These are caught by the compiler before you can even run your program. Second, runtime errors. These guys sneak past the compiler, but they cause your program to crash while it's running. And third, the most devious of them all, logic errors. This is where the program runs perfectly fine, but gives you the totally wrong answer. Let's break each one down. A syntax error is just a grammar mistake. You broke one of Java's strict rules. In this example, we just forgot the semicolon. Our strict grammar teacher, the compiler, is going to catch this immediately. It will refuse to compile the code and will usually give you a pretty helpful error message, like semicolon expected. In fact, most modern IDEs will put a little red squiggly line right under the mistake to warn you. These are the easiest errors to fix because the computer tells you exactly where to look.
A runtime error is a lot sneakier. Your code's grammar is perfect, so the compiler lets it pass without any complaints. But then, when the program is actually running, it tries to do something that's just impossible. The classic example is trying to divide a number by 0. Mathematically, you can't do that. So when the computer tries, it doesn't know what to do, and the whole program just crashes right in the middle of execution. We often say this throws an exception, which just means the program ended abnormally.
And finally, we have the most dangerous villain of them all, the logic error. This is when your code has perfect syntax, it runs without crashing at all, but it does the wrong thing. Your algorithm, your recipe is flawed. In this example, we want the average of 2 and 4, which should be 3. But because of the order of operations, the code calculates 4 divided by 2 first, which is 2, and then adds 2, giving us a final answer of 4. The computer did exactly what you told it to do, you just happened to tell it the wrong thing. These are the hardest to find because the computer never warns you. You only discover them by carefully testing your program and realizing, wait a minute, that's not the right answer.
So why did we just spend all this time on algorithms, compilers, and semicolons? Because these are not just abstract ideas, my friends. They are the absolute bedrock of what you are going to be tested on. Let's connect everything we just learned directly to your success on the AP exam.
Check this out. According to the official College Board framework, Unit 1, which covers all these foundational concepts we just talked about, makes up a solid 10 to 15% of your entire AP exam score. Let me say that again, 10 to 15%. You cannot expect to get a 4 or a 5 on this exam without having a rock-solid understanding of this material. Mastering these basics now will save you so many headaches down the road.
So what kind of questions are you going to see? Well, they love to test these common pitfalls. You'll see little snippets of code with a missing semicolon or mismatched curly braces and be asked what's wrong. A huge one is case sensitivity. In Java, main with a lowercase m is totally different from main with an uppercase m. And you can bet you will absolutely get multiple choice questions that show you a piece of code and ask, will this cause a syntax error, a runtime error, or a logic error? You have got to know the difference cold.
And that wraps up our deep dive into the foundations of Java. You now have a solid grip on how computers follow instructions, how to write your first program, and the common errors to watch out for. Hey, if this explainer helped clear things up for you, do me a huge favor and hit that like button, and maybe share it with a classmate who could use it. And of course, make sure you subscribe to Self-Study Prep so you don't miss the next part in our series. Now, for our question of the day, which I want you to answer down in the comments. If you write a program with a perfect algorithm, but you forget that very last closing curly brace, J, at the end of your class, which of the 3 error types is that, and will the program even run at all? Think about who or what checks for that brace. Let me know your thoughts below, and I will see you in the next one. Happy